An alternative method of solving dynamics problems is to represent the motion of the body graphically. The following graph, which illustrates the motion of various particles, emphasizes the vector nature of displacement, obviously of velocity and of acceleration. Here we are considering motion of a particle along a straight line. Just come to the point. So let us start in a very simple way. Consider a particle which is moving along this line. Say we are marking here x to be positive. Along this direction we will call it positive x direction. If particle moves along the straight line, means here along the x-axis, then its motion towards this side from left to right we will consider it to be positive, and in case of motion opposite to this specified direction which we have taken positive, it will be considered as negative x-axis. Now just for easiness I am saying here, say at time t1 particle is at this position which is say x1. At some other time t2 particle is here at this place, say this position is x2. At t3 time and t4 time, t5 time and so on, particles positions are x3, x4 and x5 respectively. Say after t5 time particle again comes at this position, say this is the position corresponding to x6 and here time is t6. If particle again keep on going towards the negative x direction, at time t7 particle returns back to x2 and so on. For our convenience we may take x equal to 0 or origin at any place as per our convenience. Say I am taking x equal to 0 at this position. I may take it to be 0 here, here or at this place depending upon my convenience and my mood. Now just consider we are drawing a rough sketch about the particles positions at various times t1, t2, t3, t4, t5. What will we do? We take xy coordinate system and on this coordinate system along the positive x direction we are considering time. The time which I have marked here as t1, t2, t3, t4, t5 up to t7. So I am just marking these times here on this time axis. Say t1 is here, t2 is here, similarly t3, t4, t5, t6, t7, t8 and so on. Here on the y-axis, which is the y-axis of xy coordinate system, I am taking here the position of the particle. As particle is moving along the x-axis either in positive x direction or in negative x direction, we are taking this position x on this y-axis with some scale which I may have of any type. Maybe 1 centimeter equals to 1 meter or 1 centimeter equal to 10 meter depending upon my choice. Here I am just marking these positions which I have considered during the motion of this particle. Say this is position x1, this is position x2, similarly x3, x4, x5. Again it is between x3 and x4, x3 and x4 there is x6, and as particle comes back to its position x2 again, so x2 I have marked already. Now if we make some points corresponding to the values of position and time at that position, I can take here some points. See the motion of the particle which I have given you here. Here particle was at position x1 at time t1. So I am taking particle's position at this time t1 to be x1. The another position which I have got here in the path of the particle is x2, and it is at time t2. So just for this position x2, the time was t2. So I am making this point corresponding to the position x2 in the path of the particle. At time t3, it reaches at the position x3. So the third point on the path of the particle is represented by this point, which is I am taking on x3 curve. Remember, these points are not the points lying on the path of the particle. It is just the values at different time for the position of the object. Consider again a point corresponding to time t4. The point we obtained on this curve is this. At time t5, particle reaches at this farthest point in its path, which I have considered. So I am checking position of the particle at time t5 to be here. Now at time t6, particle reaches at the position x6. S6 is taken here, so I am just taking the corresponding curve by using this scale so that I may get a particular point. Yes, at time t6, this is the corresponding point for the position of the particle on this position time curve. Again at time t7, particle reaches at its position x2 again. So for t7, I am checking the position of the particle to be at x2. Just come, this is the point corresponding to the position of the particle at time t7. Now what will we do? We just connect all these points by a smooth line so as to get the motion of the particle changing with time. Just connect. Say these points are connected by this smooth line in this manner, say in this manner. Now what this curve represents? This curve represents the rate of change of position of particle with ongoing time. Here if we talk about the position of particle at time t2, it is here, and at time t6 this position is here. If I connect these 2 points by a smooth line, what this line gives us? Obviously from this curve I may take distance from here to here, and this change in position is equal to the position x6 minus position x2. The position of the particle at time t6 and at time t2. We can take this difference to be the time difference between t6 and t2. Say this is delta t. I can write here delta t to be equal to t6 minus t2. Here x6 minus x2, I am taking it as change in position, or you can say displacement. If we talk about the term delta x upon delta t, it is the displacement between time t2 to t6, which can be obtained by x6 minus x2, and time taken in this complete motion from x2 to x6, it is t6 minus t2. Here by using the geometry, just properties of a triangle, we can say that if I consider this angle to be theta, then delta x over delta t, it gives me tan theta. What is the tan theta here? Tan theta is slope of chord to this curve between the positions corresponding to this point A and this point B on this x3 curve. So from A to B, we can write average velocity between time t2 to t6 to be equal to slope of the chord to this curve. As you know, this term delta x by delta t, it is the average velocity, total displacement upon total time. Now just consider the point A again on the curve. If I draw a tangent here on this curve, just see this line is the tangent at this point, and what it gives us, this line which is the tangent, slope to it gives us the instantaneous velocity at this time t2. The slope of tangent gives us instantaneous velocity. I think you can see here at various places instantaneous velocity can be achieved by slope of the tangent to the position time curve and average velocity between two time or a large time interval. We just have to draw a chord to the curve between those 2 points, and slope of that chord gives us the average velocity of particle between the corresponding times.